Hello everyone. In this lecture, I will discuss about the GATE and IES previous questions on graphical method topic. First problem is a manufacturer produces two type of products 1, 2 and production levels of x1 and x2. The profit is given as 2x1 plus 5x2. Then the production constraints are x1 plus 3x2 less than or equal to 40. 3x1 plus x2 less than or equal to 24, x1 plus x2 less than or equal to 10. Then we have to find the maximum profit which can meet the constraints. Let's see the solution. First we have to convert the constraints into equations by replacing the inequality symbol by equal symbol, and we have to find the coordinates values for the respective constraints. After that one, we have to plot the lines for the respective constraints and we have to mark the region for the each constraint. Here observe that then all the constraints are having the less than or equal to symbol, so we have to mark the region is below the line for all the constraints. So this is the feasible region, and identify the corner points. Here 7, 3 are the one of the corner points in the feasible region. So then we have to substitute x1 value is the 7 and x2 value is the 3 in the objective function, and we will get the maximum profit is 29. So answer is the 29. Let's see the second problem. Consider a linear programming problem with two variables and two constraints. Objective function is maximize x1 plus x2. The corner points of the feasible region are 0, 0, 0, 2, 2, 0 and 4 by 3, 4 by 3. If an additional constraint, that is x1 plus x2 less than or equal to 5 is added, then have to find the optimal solution. So this question is given in GATE 2005 for mechanical paper, and let's see the solution. First we have to identify the feasible region by given corner points. See, corner points are the 0, 0 and 0, 2. So 0, 2, and another corner point is the 2, 0, 2, 0. So another one is the 4 by 3, 4 by 3, which means so nearly 1.3. So nearly it will become so 1.3 and 1.3. So 1.3 and 1.3. So nearly it will become here, and this is the feasible region. So this is the feasible region. So after identification of the feasible region, next we have to draw the additional constraint line. So additional constraint is x1 plus x2 less than or equal to 5. Then we have to this constraint we have to convert into the equation that will become x1 plus x2 equal to 5, and coordinates values are the 5, 5. At 5, 5 we have to plot a line. So this is the additional constraint line, and here we have to consider the region is below the line. So why mean it is given the less than or equal to symbol. So we have to consider the region is below the line, and here I have to observe that one. An additional constraint is not affecting on the feasible region. So our optimal solution is 4 by 3, 4 by 3. Why the 4 by 3, 4 by 3 mean at 4 by 3, 4 by 3 we will get the maximum objective function, maximum value of the objective function. So answer is 4 by 3, 4 by 3. And finally we have to see the third problem, that is solution to z equal to 4x1 plus 6x2, and constraints are given x1 plus x2 less than or equal to 4, 3x1 plus x2 less than or equal to 12, and x1 and x2 both are greater than or equal to the 0. So this question is given in IES 1992 for the mechanical paper. Let's see the solution. First we have to convert the constraint into equations, and after that we have to determine the coordinates values for the each constraints, and we have to plot the lines by using these coordinates values. Next we have to mark the region for the each constraint. Here we have to consider the region is below the line for the two constraints, and this is the feasible region. So by observing this one, this feasible region is solution is having the unique solution. So answer is the option A, that is the unique solution. So thank you.